Hi, I'm Josiah. I made Dio, a local co-op platformer about 2 minotaurs trapped in a labyrinth. Today I'm gonna show you how you can turn your single-player game into a local multiplayer game. We're gonna start out with a very basic platformer. First, I'll show you how to easily add a second controllable character. Then, we'll add a split screen with each side following a different player. And finally, we'll have a look at how to implement collisions between players, so they can push and carry each other around. We'll start with a new project with only 2 objects in it, an empty wall object and the player object with our platformer movement. Don't worry about reading this now. We'll have a closer look at the code later. We also have a room with the player and some basic platforms in it. If you want to follow along, you can find a link to download this project in the video description. By the way, if your GameMaker looks a little different than mine, that's because I'm using the code editor too. You can enable it in the preferences under code editor too. Just check this box and restart GameMaker and you're good to go. So, let's get started by adding a second player to our game. First thing we'll want to do is set up a parent hierarchy for our player objects. Setting an object as the parent of another object will copy all of its events and update the child automatically whenever we make changes to the parent. So, in our case, we'll want one parent player object which will contain all of the movement code and 2 children, player 1 and player 2, which inherit from the parent object. Since we already have an object which contains the movement code, we'll just use this one as our parent object. Let's remove it from the room, rename it to Power Player, and remove its sprite. This will help us avoid confusing it with the new player objects we'll create in a second. We'll create a new object called Object Player 1 and assign its sprite. Over here we can assign its parent. As you can see, the code from the parent now appears in the child as well. Let's do the same for our second player object, assign it the second player sprite and the parent as well. Then let's go into our room and place these new objects. If we start the game, we can see that there are now 2 player objects. However, the sprite we assigned to the second player actually gets overwritten by some animation code. So let's go ahead and see what we can do about that. In our parent object's step event, we can see that the player sprite is being set according to some conditions. If the object is not currently on the ground, it will pick the jumping sprite. If it is on the ground and the player is giving horizontal input, it will pick the walking sprite. And if none of the 2 apply, it will default to the idle sprite. Now, since we want our 2 players to each have a different set of sprites, let's create some variables in which we'll store the corresponding sprites. We'll go to our variable definitions and add a new variable which we'll call sprite idle. Setting the variable type to asset and selecting sprite will make it so we don't accidentally set the variable to a wrong asset type. Then we'll add 2 more variables for the walking and jumping sprites. We won't assign these variables in the parent object though. Instead, we'll go to Object Player 1, which automatically inherited these new variables. By clicking the edit icon next to a variable, we can override the value it inherited from its parent. So, let's put the sprites that belong to the first player in there. Then, we'll do the same for player 2, giving it the second player sprites. Now that we have our variables initialized, we'll go back to our parent step event and replace the direct references to the sprites with our new variables. Starting the game now, we can see that the second player is animated correctly with its own set of sprites. Next up, let's give the second player their own buttons to be controlled with. Similar to how we did with the sprites, we'll add 3 more variables to our parent object. Here, we'll store the keys for controlling the player. Then, we'll go to the step event again and locate the input section. Here, we'll replace the direct references to the different keys with our new variables. The first player will be controlled with the arrow keys. So in Object Player 1, we'll set these to VK up for jumping and VK right and left for walking. The second player should be controlled using the W, A and D keys. To reference letter keys on the keyboard, we can use the ORD function with the corresponding letter as an argument. Starting the game now, each player can be controlled independently. You could even add a third or even more players using the same method. Next up, let's add a split screen. The first step will be to create a camera that follows one of our players. Let's go into our room and find the Viewports and Cameras section. Viewports allow us to display different parts of the room instead of showing the whole room at once. So let's enable them. GameMaker lets us have up to 8 different viewports active at any time. We can enable each of them by opening their panel and checking the visible box. The camera and viewport properties allow us to change the position and dimensions of the viewport. We'll have a closer look at these later. For now, we'll leave these at their default values and instead have a look at the object following settings. In here, we can assign an object that the camera will automatically follow around the room. Let's select our first player object. The horizontal and vertical border values tell the camera how close the object is allowed to get to the edge of the camera area before the camera will move. If we want to keep our player in the center of the screen, we should set this to half the width and height of the camera. Here's a little unorthodox secret though. We can make this value higher than necessary without a problem. If we set this to 9999, the followed object will always be kept in the center of the camera. This way we don't need to calculate the exact values, and even if we decide to change the dimensions in the camera later, it'll still always be centered. The last thing we can change here is how fast the camera is allowed to move when trying to follow the object. If we set this value to 5, for example, the camera will only move a maximum of 5 pixels per step. The default value of -1 means that it can move at any speed, and for our case, this is perfectly fine. Now, one more thing that's important to know about these viewport settings is that when setting an object to be followed by the camera will stay constrained to the dimensions of the current room, meaning it will stop following the object when reaching the border of the room. In our case, the room is currently only the size of the single screen, so the camera would actually end up not moving at all. To allow the camera to follow the player around, we'll have to make the room bigger. Let's double its width and height in the room settings and then select all of the objects by holding Shift and move them to the center of the room again. And as you can see, we now have a camera following one of the players wherever it goes. Now, since we want to be able to fit 2 cameras into our game window, we'll actually have to make each of them only half as wide. To do so, let's have a look at the viewport settings. In the camera properties, we decide the camera's position and dimensions in the room, while in the viewport properties, we decide its position and dimensions on the screen. In most cases, you'll want to keep the dimensions of the two proportional to each other. So, how do we halve the width of our camera? If we only change the camera width, our game window would end up getting stretched to still fit the full viewport width. If we only changed the viewport width, our window would have the correct size, but its contents would be compressed. So we need to adjust both. And voila, we now have the first half of a split screen. Now let's add a second camera. Once again, we'll enable another view, set the object to be followed, and set the border values absurdly high. Then we'll have both of its camera width and viewport width. However, if we start the game now, we still don't see our second camera. That's because our cameras are now both drawn on top of each other. To make them be displayed next to each other, we'll have to move one of them to the side by changing its viewport position. Let's set it to 512, so the second view will get displayed directly next to the first one. Now, if we want a little more control over the camera, we can also move it using code. Let's have a quick look at how to do that. Let's remove the following object from the views so we can write our own camera movement instead. First, we'll add a new variable to our parent object called camera index. We'll use this to assign which camera will follow each of the players. Player 1 will get camera 0 and player 2 will get camera 1. Next, in the create event, we'll use view camera to get a reference to the camera corresponding to the player's camera index. We'll be needing this reference for any functions that manipulate the camera. Next, let's go to the step event and add a new section for the camera movement. To set a camera's position correctly, it's important to know that its origin is on the top left corner of the area that it's showing. So, if we want to center an object within the camera, we'll first have to calculate its center and offset the camera position by that value. We can do this by using camera get view width and dividing it by 2. And then doing the same for view height. Finally, we can use camera set view pos to set the camera's position. We'll set it to the player's position minus the offset value. As you can see, this is functionally identical to using the built-in camera follow. But using code allows us to adjust the movement to our liking. Let's see if we can make the camera follow our player smoothly using a lerp function. We'll add two more variables called camX and Y to the create event. Then we'll use a lerp function to gradually move these towards the player's position each step. And finally, we'll just replace the player's X and Y position in the camera set viewPos function with camX and camY. As you can see, the camera now gradually follows the players, which looks a lot smoother. Next up, we'll want to add collisions between our players. To do that, we'll have to have a quick look at our movement code. As you can see, it's quite straightforward. We have speed X and speed Y variables that we use to calculate the player's movement. Pressing the jump key will give the player upwards momentum, and while being in the air, gravity will constantly accelerate it downwards. The player's horizontal speed is set according to the directional key currently pressed, if there is no wall blocking its movement. Finally, move and collide is used to move the player object according to speed X and speed Y. Move and collide moves an object in a direction while avoiding collision with another specified object. In our case, since we don't want our players to move into the walls, we avoid object wall. If we want our players to not be able to walk into each other, we can just add another object to avoid. To do that, instead of providing a single object as the last argument, we can put an array containing various objects. So we'll just include parPlayer in here. Then we'll go to the beginning of the step event, where we assign a variable called onGround. This is used to pick the correct player animation and to determine whether the player is allowed to jump or not. Since we want our players to be able to jump off of each other, we'll add parPlayer to this function as well. And just like that, players can now stand on and jump off of each other. Another fun interaction between players is allowing them to push each other around. To implement this, we'll first check if there is another player in whatever direction we're currently walking in, and if there is, we'll move the other player out of the way. We'll do this before the movement of the player itself, so the push player doesn't block the pushing player's movement. We'll create a new variable called playerInFront and use instancePlace to check for collision with another player object. To check in whichever direction we're currently walking in, we'll add the walking input as an offset to the X position. However, using an offset of only a single pixel for collision detection can sometimes be a little inaccurate. So, to avoid that, we'll multiply the walking input by 2, meaning we will check for another player up to 2 pixels ahead. Then we'll add a with statement, which allows us to run code from within the colliding object. To push it, we'll use move and collide. As the X value, we'll want to use the current walking speed. However, writing it like this, we would be using the walking speed of the object being pushed. We want to be using the pushing object's walking speed instead. So we'll use the keyword other. This references whichever object originally called the with function. As you can see, players can now push each other around. To make the pushing look a little more realistic, we can divide the speed by 2, so pushing is slower than regular walking. Next up, let's see if we can make players carry each other around. We'll use a very similar approach to pushing, so let's once again start by using instancePlace to check for a collision with the player object. This time, we'll want to check the position just above the player, so we'll put y-2 as the second coordinate. Then we'll once again use with to move any player object on top in the same direction as the carrying player's movement direction. This time, we'll also move it vertically, so if the player below jumps, the player above will get pushed upwards as well. And voila! Players can now give each other a piggyback ride. Now, if we wanted to, we could leave it at that. There's just one little thing that doesn't quite work as expected yet. As you can see, the upper player currently gets detached from the lower player mid-jump. That's because when the lower player starts falling, it will attempt to pull the player on top down with it, but block its downwards movement at the same time. This is where we have to start thinking carefully about the execution order of our code. Currently, the player moves the other player on top before it moves itself. This is great when moving towards the other player, while pushing or jumping up, because it will move the other player out of the way to make space for its own movement. Just for comparison, this is what it would look like if the carrying player executed its own movement before moving the other player. Jumping looks very janky because the jumping player is constantly colliding into the player above. However, during downwards movement, we'll actually want to move the carrying object first, so we can then pull the other player down as well without it getting blocked. The solution to this is simpler than it might seem. We'll just add an if condition to check if the player is currently falling or not. If speed y is negative or 0, that means it's not falling, and we'll keep the order of execution as it is. But if the player is moving downwards, we'll just execute the rest of the movement in reverse. We'll move ourselves first, and then the object we're carrying. With that change, we can now carry the other player without them falling off whenever we jump. And there you have it. Just like that, we've converted our single-player platformer into a local multiplayer game. You can find a link to download this project in the video description, so feel free to play around with it. That's it from me. Stay tuned for more tutorials on this channel, and happy game making!